So, we're going to talk about today phases of matter. And when we think about the phases of matter, we are going to think about movement of the molecules. So, we have a theory. It is called the kinetic molecular theory of matter. And when you hear the word, that vocabulary word kinetic, I always want you to think of movement. So, kinetics means the force of movement or the movement of something. So, kinetic energy is going to be energy of movement. Potential energy is going to be static energy, energy that is stored, where something is staying still. So kinetic means movement. So here we have a diagram where you can see some particle diagrams of a solid, liquid, and a gas. And you can see there's these little lines. Those lines in that model are representing the movement of a molecule. The movement is going to vary based on the amount of energy that is put in or absorbed by a substance. So solid is going to have the least amount of kinetic energy. It's got the least amount of movement. Now, we are always under the theory that matters are constantly moving. So matter is always in constant motion. Once it stops moving, we are in the theoretical realm of it no longer existing. Okay, so think of it as if matter stops moving, it's no longer matter. Okay, so it's always got to be moving. So solid's going to have the least amount of movement. The atoms are they're stuck in place. So they're not actually physically moving around. They're going to be in a fixed location. And what they're doing is they're vibrating. So they're sitting there in the same spot, but they're vibrating. These atoms are vibrating in their bonds. They're not moving around in their bonds. They're just vibrating back and forth. So think of a really hyper kid stuck in a chair and he's just kind of like rocking back and forth. He's still in the fixed position, but he is moving. So that's how we're going to think of our solid particles. They are in a fixed position, but they are vibrating back and forth. You add a little bit more kinetic energy, we're going to start overcoming those attractive forces that make them in a stuck position, and they're going to start sliding back and forth. So in a liquid, we have more kinetic energy, and we're now sliding back and forth past one another, and this is what's going to create flow. This is going to create that fluid mechanics that we see with liquids when they flow out of a container when you pour it, or just think of a river flowing downstream. Okay, that's because these particles are actually starting to slide and move past one another. Now, another thing you want to notice with a liquid is they are still very close together. Okay, they don't have to be in contact with one another, but some of them are. And then we bring it to a gas. So if we create and input even more energy, the molecules are going to spread even further apart, and they're going to be moving at a quicker rate. They're going to be, think of like ping pong, all right? The ball moving back and forth, back and forth. That's what a gas is like. So gases are going to have the most kinetic energy. And then you would get into the fourth phase of plasma, but we're not going to talk about that in this course.